Hello, welcome everyone, welcome back to my channel. Today we are starting exponential growth and decay, and before that I'm running GCSE classes at just £6 per hour, and if you need classes for any subject from year 1 to A levels, they are highly affordable, and for any subject we are providing all those subjects. So just email us at exactacademy@gmail.com and we'll coordinate from there. We'll book a free demo first. Also, I'm running Easter classes for GCSEs and A levels, as well as I'm running test series, so you can appear for the test series, and also I'm selling the mark papers as well at very affordable rates. So for all that, just email us at exactacademy@gmail.com and we'll coordinate there. So let me start with exponential growth and decay. Well, the general way of writing is y is equals to a e to the power of k times t, but this e is not in your syllabus, so we'll be using another formula, which is, let's say, a is equals to small a, or we can use any term, any acronym or any letter for it, 1 plus r to the power of t. So this will be using. Now before that, let me explain you what it means by exponential growth and decay. So exponential growth or decay, that means when something is constantly decreasing. So say for example something is 100. Now we say that it has decreased by 10% in the first year. So now it's 90. Again it will decrease by 10%, but important thing is 10% on this now. So 10% of 90 is 9. So now it will be 81. Now again next year it will again decrease by 10%. So 10% will be on this, and 10% of 81 is 8.1. So we have to subtract 8.1 from 81 and so on. That's called exponential decay. Similarly, if it's 100 and if it's increasing by 10%, it's going to be 110. There will be an increment of 10%. Now again 10% will be there, but on 110. So 10% of 110 is 11, so it will become 121. Now again it will increase by 10%, and 10% of 121 is 12.1. So there will be an increment of 12.1. So that's the meaning of exponential growth and exponential decay. It's increasing and decreasing exponentially, and that's the reason their graph looks like this. You can see this is the graph of exponential growth. It's exponentially increasing here and going up there, and this is exponential decay where it's decreasing and going down there. Well, coming back to the formula which I have given, I told you that the formula we will be using is a times 1 plus r to the power of t is equals to y, whereas this stands for initial amount. We'll be doing questions. This question you can clearly see here, but let me discuss the formula first. So this describes the initial amount. Always this describes the initial amount. If you read this question, a car costs £23,000. The value of car decreases by 10% each year. That means your 23% at £23,000 is the initial amount. So in this case, this small a will become 23000. And 1 plus r represents rate percent, by which it's increasing or decreasing. Because I'm using plus sign, it means it's increasing, and if I'm using minus sign, a times 1 minus r to the power of t to equals y, that means it's decreasing. It's obvious. If it's something is increasing constantly, you will be using plus, whereas if something is decreasing constantly, we'll be using minus. So in this question it says the value of car decreases by 10% each year. That means we have to use -1. This formula will be using. Formulas are exactly the same, only the sign is different. So r is rate percent, so I'll be writing 23001 minus 10% to the power of t. Now we can't use percent, we have to convert it into fraction or decimal. So obviously when I'll convert percentage into a fraction or decimal, this we have done in like year 4 5 thing. So this will be 10 over 100, which will give you 1 over 10 or 0.1. So we have to focus on this formula. These two formulas will be using a times 1 plus r whole to the power of t when it's exponentially increasing, and a times 1 minus r to the power of t when it's exponentially decreasing, where a is the initial cost, initial value, r is the rate percent, and t is the time. That, like keeping that in mind, let me do this question. This question says a car costs £23,000. The value of car decreases by 10% each year. Write an exponential model to represent a car's value after t years. So obviously we'll be using a times 1 minus r to the power of t. A stands for the initial value 23,000, 1 minus 10 over 100 to the power of t, or you can write 1 over 10 or 0.1, or directly 1 minus 0.1 will give you 0.9. So you will get 23,000 times 0.9 to the power of t, and that's your exponential model. Moving on to the next part, calculate the cost of car after 5 years. We do have our model, which is 23,000 times 0.9 to the power of t, and t is the time, and in this case it's 5. So the final answer will be 13,581.27 pounds, and that will be the cost of the car after 5 years. Moving on to the next question. The population of an area in 2020 was 10,000. The annual rate of increase was 2%. Predict the population in year 2030, and it's increasing every year clearly. So we'll be using a times 1 plus r to the power of t. A is the initial amount, which is 10,000 in this case. 1 plus r is 2%, which is 2 by 100 whole to the power of t, and we have to see how many years. Looking at it, we can clearly see it's going to be 10 years, but still this was the population in 2020. So 2021 will be the first completion of first year. 2022, 23, 4, 5, 6, 7, 8, 9, 10. That means 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and these are 10 years. That means in 2030 it will be the complete 10 years, so it's going to be 10 up there. So 10,000 times 1 plus 0.02 whole to the power of 10, which is 10,000 times 1.02 times to the power of 10, and when we'll multiply it, we'll get answer as 12189.9. that will be the predicted population, but obviously 0.9 cannot be the predicted population, so it will be 12189 will be the population. Now the question is why I haven't taken 90, because 0.9 will not complete one man. Okay, so we can't assume that okay, one man will be completed. No, we have to see till complete one are 12189. So that's why this is the predicted population in year 2030. Moving on to the next question. Jamie bought a house, and since the value of his house will increase every year, the value of his house is given by v is equals to 80,000 times 1.1 whole to the power of t, whereas v is the value of house in pounds and t is the time period. Find the value of the house when the Jamie bought it. As I told you, a is equals to a times 1 plus r to the power of t will give you this one as the original value, the initial value. This is the rate percent, this is the time, this is the final value. So we can clearly see that this A is what in this case? 80,000. So 80,000 pound is the initial value of the house. This is the value of house when he bought. Also, we can calculate it because when he bought the house, time was 0, obviously. So it will be V is equals to 80,000, 1.1 to the power of 0. Anything to the power of 0 is always 1. So answer is 80,000. So 80,000 pounds is the initial value. Calculate the value of the house after 5 years. So only we need to replace T with 5. That's it. So substituting this value, V is equals to 80,000, 1.1 to the power of 5. When I put this in calculator, I'll get the answer as 128.80.8 pounds. So that will be the value of house after 5 years, because it's increasing. You can clearly see it's increasing tremendously. And that's it. In the next question, calculate the percentage at which the value of house is increasing every year. We just need to compare this with our initial equation, which I should write right here by its side. So a is equals to small a 1 plus r whole to the power of t. And this r is what? When I convert the percentage into a number or a fraction, it will be a times 1 plus r over 100 to the power of t. Similarly, 80,000 is a, that's initial value. Only we have to look into this one. 1.1 can be written as 1 plus 0.1 whole to the power of t. And 0.1 is what? 10 over 100, because 0.1 is 1 over 10. But obviously r over 100 is equals to 0.1. So from here, if it's difficult to understand, this is the breakage. 80,000 1 plus 0.1 whole to the power of t, and I have broken it because so that I can easily compare it with my standard equation. On comparing, a is 80,000, which is the initial value clearly, and r over 100 is equals to 0.1. So r will be 10%. So every year it's increasing by 10%. So let me just write down. On comparing, a is equals to a times 1 plus r to the power of t. V is 80,000, 1 plus 0.1 to the power of t. So 0.1 is equals to r over 100, or let me specifically write like this, and r will be 10%. So answer is every year it's increasing by 10%. It says after how many years the value of house will become double. So 80,000 will become double. That means it will become 1,60,000. So in place of V, I'll write 1,60,000. And this is 80,000. Or it was 1.1. So let me just directly write 1.1 to the power of t. This t we have to calculate. So divide both the sides by 80,000. You will get 2. 1.1 to the power of t, and it's just hit and trial method to get the value of t. So just put t equals 1, 2, 3 and so on, and see what value you will get. One thing that's easily you can understand is when t was 5, value was 1,28,840, and we want 1,60,000. That means definitely t is going to be greater than 5. So don't try 1, 2, 3, 4, 5. At least this will release a burden, this will decrease your work. So now you can put t equals 6, 7, 8 and 9 and see what answer you'll get. So let me put when t is equals to 6 and see what's the answer. On putting t equals 6, we'll get 1.1 to the power of 6 is 1.77. Now let me try 1.1 to the power of 7. So that will give you 1.94. Again, let me put 1.1 to the power of 8, it will give me 2.14. We want 2, so clearly we can understand that the value will lie in between 7 to 8. So we can use 7.5 as well. So let's see whether 7.5 will give me more accurate answer or not. So 1.1 to the power of 7.5 will give me 2.04, which is, yes, approximately equals to 2, right? That means approximately after 7.5 years, the value of house will become double. Well, so that's it for today. I have given you the information, like the brief description of what is exponential growth, what is exponential decay, and compound interest is also an example of exponential growth. So we'll be using the same formula in case of compound interest, which is a times 1 plus r over 100 to the power of t, because compound interest is always about the increment, so it's an exponential growth example. So this is the formula that we have to use while doing questions on increasing, decreasing, compound interest when something isn't constantly increasing. And we have done a few questions to understand it. We have seen its graph as well. So in the next video, we'll be doing questions on it to understand it in a better way and to understand the type of question being asked in GCSEs. Okay, so that's it for today, and if you need the free worksheet, this one where the written material is given, or the free worksheets where the questions are there, they are entirely free and available on www.exaacademy.com. So that's it for today. Bye everyone, take care.